everybody, it's Miss Phoebus, and this is lesson 36, solving quadratics by factoring and graphing. So factoring and graphing are things that we've been doing, and so we're just going to take it one step further. So a lot of this is going to be pretty straightforward. I'm not going to have to do a whole lot of teaching. I'm just going to be working a lot of examples because you already know how to factor. You already know how to get zeros from factors. You should be graphing. That's what we've been doing in the last 3 lessons. And then we're going to use the graphs to help us find the zeros. So all of this ties back to the very first lesson that we looked at, linking factors and zeros. All of the stuff that we talked about there, we are using here. So I can identify the zeros of a quadratic equation by factoring. I can identify that when a quadratic is not factorable, it does not cross or touch the x-axis and therefore has no real zeros. So we're going to factor a quadratic, we're going to identify zeros, we're going to graph quadratics and look at their intercepts. We're going to solve quadratic equations in one variable by factoring, and we're also going to look at graphs. So when we have a function, we're going to factor it so that we can show the zeros. So here we go, page 160. On 160, we have the zero product property happening again. I just want to remind you that it says if I'm multiplying two numbers, in this case a times b, and that equals 0, then a has to be 0 or b has to be 0. The zero product property requires the equation to be set equal to 0. Rearranging may be necessary. I have to move some pieces around. Now, I want my leading coefficient to be positive, especially if I'm doing like a slide and divide. So it may be easier to move this negative 3 over so that I have 2x squared plus 17x plus 3 equals 0. So that's when I say I need to set it equal to 0 and I may have to move some things. That's what I'm talking about. Before applying the zero product property, the equation must be fully factored. If it's not fully factored, you may miss something. You're going to use this method when you can factor a quadratic. Now, if something is unfactorable, this is not the best way to do it. And I have other methods that we're going to explore next week. But all of these are going to be able to be factored. You should not be writing unfactorable in this lesson. So, remember that it has to equal 0. If it doesn't equal 0, we have to rearrange it. So in number 1, x squared plus 18 equals 9x, it doesn't equal 0. But if I move this 9x by subtracting 9x, moving it to the left-hand side, I want to make sure it's written in standard form. Now it equals 0. Now I'm ready to factor. Can we find two numbers that multiply to give us 18 and add to give us negative 9? Negative 6 and negative 3. So that means I have x minus 6 and x minus 3. Now, a lot of times people get confused. They're like, when do I factor and when do I find zeros? So the key is that I have this equals 0 component. If I just had x squared minus 9x plus 18, if I just had that no equals 0, all I could do, or all I would be able to do is stop right there with the factored piece. But because I have the equals 0, I have to set each piece equal to 0 and solve for x. Now, you don't have to physically write out the equals 0, but I do want to see that you found x equals 3, x equals 6. I should see some evidence of factoring, so I should see some parentheses because I want to see what you factored it to, how did you get those answers, and then what made you get these. But that's it. I can check by plugging this x values back into the original equation and seeing, do I get something where the left hand equals the right hand side? I could also graph this if I'm 100% sure that this and this are pretty much the same thing. And I can see, does it look like my graph crosses at 6 and at 3? Are those the x-intercepts? So you can use the graphing calculator to check. You can even use the table to check. but these should be relatively nice numbers. We might end up with some fractions, but you set it equal to 0, you factor, and then you tell me what the zeros are based off of that. So, number 2, does it equal 0? No. What are we going to move? The negative 54. How are we going to move it? Add 54 to both sides. So I have x squared minus 15x plus 54 equals 0. Don't forget the equals 0. I need to find two numbers that multiply to give me 54 and add to give me negative 15. Those are negative 9 and negative 6. Now, a lot of times people are like, I want to go straight to the answer. And I understand the desire to do that, but I still want you to process this as a factoring problem. So we're still practicing this factoring component. So x minus 9, x minus 6 equals 0. X minus 9, what's the 0? 9. X minus 6, what's the 0? 6. There are your two solutions. Now, sometimes you'll see it written like this, 9, 6, or even 6, 9, but they're not in parentheses. Those are two separate points, right? Two separate zeros. But you could write them in your braces. Remember that like a discrete answer, you could write it like that. I think they do that a little bit on the ACT. Not so much, but a little bit. All right, let's look at number 3. Does it equal 0? No. Let's add 4 to both sides. So I get 2x squared plus 6x plus 4 equals 0. Now, there's a 2 in front of my x squared, so that means I need to slide and divide. However, do you see that there's a greatest common factor? Let's factor out a 2. So we end up with x squared plus 3x plus 2 equals 0. And so we want to find two numbers that multiply to give us 2, add to give us 3. Then these numbers are 2 and 1. So I have 2, x plus 2, x plus 1 equals 0. And then x plus 2 equals 0. X would equal negative 2. If x plus 1 equals 0, x equals negative 1. Now, some of you might be like, well, what happened with this? The greatest common factor is a part of your factoring answer. But the only time that the greatest common factor contributes to a 0 is if they have an x. So do you see how this 2 has no x? It is not involved in the answer. Okay, it is there to help you multiply and get all the way back up to what we originally started with, but it is not involved in the answer. Now, if it was like 2x, remember sometimes our greatest common factor has a variable with it. If there's a variable with it, then we have to set it equal to 0 and solve for that variable. Now, if you notice down here, I have this like purple box that says ACT, find the sum of the zeros. The ACT will have you do something extra. They're always like, hey, work this problem, and oh, by the way, before you leave, you also need to do this extra thing. And so one thing that they'll have you do is they'll ask you find the sum or the difference of the zeros, or even the product. Sometimes that happens. So what would happen if I did negative 2 plus negative 1? What would I get? Negative 3. So that is something that the ACT likes to do occasionally. It'll pop up because it's not directly tied to the solving of this problem. You can't plug negative 3 in for x and get negative 4 to come back out as your answer. It's not going to work. So the thing is that they want to give you a problem and a way to know that you actually did the work and found the zeros, and then they want you to be able to give an answer doing something with those. These are really the zeros, but that negative 3 is what would be the answer if I added those together. All right, number 4. Hey, it equals 0. We don't have to do that step. That's good. So it already equals 0. I think we have a common denominator. Do you see that? I think we have a greatest common factor. Do you see? I think it's a 3. Let's factor that out. If I factor out that 3, I don't have to do slide and divide. which should make most of you happy. I know there's a few lovers of the slide and divide. I am one of those. But if I factor out of 3, it makes my number smaller, easier to factor. Can you come up with two numbers and multiply to give you 10 and add to give you 11? They are 10 and 1. All right, remember 3 is a part of the factoring answer, but it's not a part of the zeros answer. So if x plus 10 equals 0, x would equal negative 10. If x plus 1 equals 0, x would equal negative 1. Remember, we're just looking at the opposite. I see positive 10, my answer is a negative 10. I see positive 1, my answer is a negative 1. Now, let's look at that sum. Let's pretend it's the ACT. What's the sum of my zeros? Negative 10 plus negative 1, negative 11. That's the sum of my zeros. Okay, but really, like, unless you're asked the sum or the difference, like, they would have to spell that out for you. Unless you're asked the sum or the difference, really, x equals negative 10 and x equals negative 1. Those are your zeros. That's your real final answer. All right, let's look at number 5. Does it equal 0? It does not. So let's make it equal 0. Now, I would highly recommend keeping my 8x squared. I would recommend keeping that positive. So I'm going to subtract 20x. It is possible to move the 8x squared to the left, but then that would create a negative leading coefficient. So it might be something that you might not want to handle. So you might need a little bit of planning ahead of time. Now, notice that I'm missing my constant. So because I'm missing my constant, the easiest and actually the best thing that I can do is just find a greatest common factor. So let's play around with that. So let's see, 8 and 20, I would say greatest common factor 4, x squared and x is the greatest common factor. All right, so that would mean 8 divided by 4 is 2, x minus 5 equals 0. So here is where the greatest common factor is part of the zeros answer because there is an x. So because there is a variable means that I have to set equal to 0 and solve. So if 4x equals 0, divide by 4, x is 0. All right, let's look at this one, 2x minus 5. You might not be able to tell by looking at it, but let's solve for x. So it has to equal 0, by the way. We're going to add 5, so 2x equals 5. Divide by 2, x equals 5 over 2, or 2.5. So I have my 2 zeros. So if there's only 2 terms, and it's your x squared and your x term, greatest common factor is probably the way to go. But you have to make sure it's set equal to 0. Let's look at number 6. Does it equal 0? It does not. So I have 2 pieces that I'm going to move. I'm going to move that 11x by subtracting it. And I can go ahead and subtract that 5 as well. You can do multiple things as long as you keep up with the pieces and make sure they're in the right spots. So this is x squared. 2 minus 11 is negative 9x. 25 minus 5 is 20. Equals 0. All right, let's find 2 numbers that multiply to give us 20, add to give us negative 9. I'm thinking negative 4 and negative 5. So that's going to be x minus 4, x minus 5. And so what makes x minus 4 equal 0? 4. What makes x minus 5 equal 0? 5. All right. So here's 7 and 8. I want you to pause the video, see if you can figure out what to do. And if you get stuck, unpause the video and I'll show you what to do. All right, number 7. I'm going to subtract 8x. I want this to equal 0. So I have to move the 8x over. So 15x squared minus 8x plus 1 equals 0. Is there a greatest common factor? No. So this is a slide and divide problem. So let's slide the 15 to the end, multiply it times 1. So we've got x squared minus 8x plus 15 equals 0. So two numbers that multiply to give 15, add to give us negative 8. They are x minus 3 and x minus 5. Now, remember, I did slide, so I have to divide it. I know it's really tempting right now to just say 3 and 5 and move on. But I have to do that division piece. So I'm going to divide by 15. Divide by 15. And so I've got x minus 3/15 is 1/5. And 5/15 is 1/3. Now, the goal is to find the zeros, right? I have equals 0. So I don't have to move that denominator up in front. What is the opposite of a negative 15? What's the opposite of a negative 1/5? Positive 1/5. What's the opposite of negative 1/3? Positive 1/3. Now this is a beautiful one. Find the sum of the zeros. We have to add 1/5 and 1/3. Okay, but they don't have a common denominator. But if you look here, they had a common denominator of 15, right? So that's really 3/15 plus 5/15, which is 8/15. So that would be the sum. But remember that these two right here, these are really truly the answer. This is just the idea that you can do other things with those numbers. All right, you ready to look at number 8? 7, 29, 4, there's equals 0, so we're not having to move anything. So I'm feeling slide and divide coming on. Let's slide that 7 to the end. Two numbers that multiply to give you 28 and add to give you 29 are 28 and 1. All right, don't forget you have to divide. We slid the 7. We have to divide by 7. So I've got x plus 4 and x plus, I'm going to go ahead and leave it as 1/7. If you want to move that denominator, that's fine. But what's the opposite of 4? Negative 4. What's the opposite of positive 1/7? Negative 1/7. Those are your answers, but let's do the ACT part. Find the sum. What's negative 4 plus negative 1/7? Negative 4 and 1/7. All right, so we're factoring. The main things are make sure it's equal to 0. You've got all your factoring skills that you have learned, greatest common factor, slide and divide, regular factoring, even your perfect square and your, remember where your parentheses look almost the same, one's got a plus, one's got a minus, all of that stuff works. It's just them taking it one step beyond the parentheses and tell me what the 0 is. All right, so these are just some more problems. I feel like we should be doing okay. If you want to try these, and email me if you want to check and see if you got these right. But I'm going to go ahead and move on. I want to get to the graphing, which is on page 162. And on page 162, we've already looked at this type of thing, 3 types of graphing solutions. Remember that if I have 2 x-intercepts, I have 2 solutions. If I have 1 x-intercept, it's 1 solution. And then if I have no x-intercepts, it's no real solution. And you need to get that word real in there. No solution isn't good enough. It's no real solution. So if you need to highlight it, underline it like 17 times, do that. Okay, but we're looking at when I graph, and we graphed in 10A and 10B and in 10C, can I tell how many zeros and maybe even where they are? Now, it is possible we may have to estimate a little bit, but for the most part, I feel like we should be able to have nice numbers. I'm not going to commit to that, but you should be having nice numbers. So you're going to use this method when you can see the solutions. If, like, I go to stick this in the graphing calculator and I hit graph, I can't see the solutions. It means probably graphing it is not going to be the best method. There should be maybe a better method. When approximate answers are okay, if I tell you I want exact solutions, there is a different way that I'm going to teach you again next week. So if decimals are okay, you can use a graphing calculator. Remember that little left bound, right bound thing that I was showing you in the calculator? If approximate answers are okay, it says round to the nearest tenth, round to the nearest hundredth. Then you could use the graphing calculator to help you there. So we're going to find the solutions by graphing the quadratic. Now, again, these have to equal 0. So in number 1, it already equals 0, so we're good. But in number 2, we're going to have to do a little bit of maneuvering and try to get it to equal 0. These are in standard form. You can factor if you want to help you find the zeros. But remember, not every quadratic is factorable. We will have times when decimals are going to be when it crosses the x-axis, and that means that we couldn't have factored that problem to begin with, because factors give us nice numbers. So what I want to do is I want to just focus on that whole standard form. Remember how to find the vertex? Negative b over 2a. That's what I want to do. Negative b over 2a. And our b value in this case is 2, so this is going to be negative 2 over 2 times, my a is 1, so 2 times 1 is 2. So that means my vertex is negative 1, comma something, right? Negative 1, comma something. So let's figure out our something. So negative 1 squared plus 2 times negative 1 minus 3. So negative 1 squared is 1. 1 minus 2 minus 3. 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So negative 1 comma negative 4 is my vertex. I'm going to erase all of that so I can show you my vertex. Negative 1, negative 4. Now that's a nice number. My a value is 1. Not a fraction. So you remember that pattern I was talking about a couple of videos ago? That 1, 3, 5, 7 pattern? This would work here. So from my vertex, I'm going to go up 1, right 1. Then I'm going to go up 3, right 1. Then I'm going to go up 5, right 1. And then I could go up 7, right 1. But I'm not going to do that because I would run out of space. So then now I'm going to mirror image those on the other side. But you should see I already have a 0 available. I do want to get that good graphing practice in. So, there's my other 0. So I am graphing. And again, you can use a graphing calculator. I'm okay with that. What are our zeros? So it looks like it's crossing at 1 and it's crossing at negative 3. So 1 and negative 3. Or 1 and negative 3 if you prefer. If you want to wrap them in the curly braces, you can, but no parentheses. That is not a point. 1 comma negative 3 is not even on this graph. Okay? We want zeros, so we want those two values. Can you get that from a graphing calculator? Sure. Could you factor this? Absolutely. But you need to, and when I'm telling you to graph, I want to see the graph and I want you to be able to pull what the zeros are, the solutions are from that graph. All right, let's try number 2. It has to equal 0, so that would mean I need x squared plus x minus 20 equals 0. All right, I'm going to do negative b over 2a. You ready? X equals negative 1 over 2 times 1. So that's a negative 1/2. Ooh. All right, let's try to figure out what negative 1/2 squared is. Negative 1/2 squared is 1/4. 1/4 minus 1/2 is a negative 1/4 minus 20. That is a very small number. I'm not going to be able to graph that. My graph only goes down to negative 10. What else could I do? Well, could I factor this? Is it factorable? Let's look. That might be a different way to handle this. So remember, I'm not looking at this anymore. I'm looking at this. So two numbers that multiply to give us negative 20 and add to give us 1. How about 5 and negative 4? Okay, so if I'm factoring to x plus 5 and x minus 4, what are my zeros? Negative 5 and positive 4. So negative 5 is right here, positive 4 is right here. So we've got our zeros, but I still want to see some stuff on the graph. So let's see if we can get some other points on the graph. So let's try 3. What's 3 squared plus 3 minus 20? Well, 3 squared is 9, plus 3 is 12. 12 minus 20? 12 minus 20 is negative 8. So 3, negative 8. And then think back to that axis of symmetry. That would mean negative 4, negative 8. And I'm going to be mean. We're going to do one more point. But know that it's like way down there. You're not going to be able to graph that piece. But let's get what we can on there. Let's plug in 5. I'm plugging in positive numbers. Plus 5 minus 20. So this is 25 plus 5, which is 30. 30 minus 20 is 10. So I plugged in a 5 and I got a 10. So you have alternatives. You could also plug it in the graphing calculator and see what you get. But I do want to see a graph, and from that graph I should be able to see zeros, and you should be able to tell me what those zeros are. So you can do factoring and graphing at the same time. You've got all the skills. All right, so find the solutions by graphing the quadratic. Let's look. Let's see. Well, 2x squared plus 8x plus 8 would be the first thing that I would do. Make it equal 0. Let's do the vertex. X equals negative b over 2a. So negative 8 over 2 times 2. That's going to be a nice number. That's negative 8 over 4, which is negative 2. Let's plug that back in. 2 times negative 2 squared plus 8 times negative 2 plus 8. That's going to be 2 times 4 minus 16 plus 8. So that's 2 times 4 is 8. 8 minus 16 is negative 8. Negative 8 plus 8 is, 0. So I'm at negative 2, 0 right there. Now, believe it or not, that's the 0. But, so we can write x equals negative 2. Let's do that. X equals negative 2, but let's build the rest of the quadratic, right? So our a value is 2. So remember that pattern 1, 3, 5, 7? Well, what we have to do is we have to multiply that by the a value, which is 2. So multiply all of those by 2, our pattern becomes 2, 6, 10, 14, which we're never going to be able to hit 14 unless our graph paper is huge. So we're going to go up 2, right 1, up 6, 1, 2, 3, 4, 5, 6, right 1. And I can tell that is my y-intercept because if I plug in 0 there for x, I do get 8. And then just get those mirror image points. So all of this stuff, the factoring, the graphing, all of that works together, and you can pull from what you need. Could this be factored? Let's see. There's a greatest common factor of 2. X plus 4, x squared plus 4x plus 4. Can you find two numbers that multiply give you 4 and add to give you 4? 2 and 2, they're the same number. That's why there's only one solution. It's one of these guys, where it can be written as something squared. So that's interesting. Do you think it's interesting? I think it's interesting. Let's see some more graphing. All right, number 4. We first have to make this equal 0. Now, it's a 4x, so I have to make sure after I move it that it's in standard form. If it's not in standard form, it's not going to graph very well. So I'm going to subtract that 4x and make it equal 0. All right, so let's look at finding the vertex. So x equals negative b over 2a. So negative 4 over 2 times 1 is 2. So that is 4 divided by 2, which is 2. Then we're going to square that 2, minus 4 times 2 plus 9. So that's 4 minus 8 plus 9. So that's negative 4 plus 9, which is 5. So 2, 5, right there. Like my A is 1, so I can use that pattern, that 1, 3, 5, 7, etc. All the odd numbers. So I'm going to go up 1, right 1, up 3, right 1. And if you don't like that pattern idea, you can always plug in 3 into your originally, not your original, but into this equation. You could plug in 3, you could plug in 4, and then mirror image those points. Also work. All right, so there's my parabola. Where does it cross the x-axis? It doesn't. This does not cross. So it has, and this is our final answer, no real. Should you write real? Yes, you should. Solution. Okay? It does not cross, so I can't give a solution. Where does it cross the x-axis? Who knows, right? You don't have an answer to give, so the answer you do give is no real solution. All right, so we got one more. What we're going to do is we're going to make this equal 0, and I know that some of you may want to multiply that out, but let's try not to for right now. So I still want to make this equal 0, so I'm going to do negative x minus 1 squared plus 9 equals 0. And this is vertex form. This is the one that you watched yesterday in the video. Remember, this tells you left or right. This tells you up or down, and this is going to be a reflection, right? Because it's a negative 1. So we're going to go right 1. We're going to go up 9 to get our vertex. So right 1, up 9, bam, there's my vertex. My A value is 1, so my pattern of 1, 3, 5, 7 gets multiplied by negative 1, becomes negative 1, negative 3, negative 5, negative 7. So I'm going to go down 1, right 1, down 3, right 1, down 5, right 1. Ooh, I can even go down 7, right 1, and then I can mirror image that on the other side. Looking there. Ooh, did we find the zeros? There's one of them. Negative 2. Here's the other one. 4. So negative 2 and 4 are my zeros. So you have a lot of capabilities as far as graphing goes because I've shown you different things. You can graph in factored form. Can you factor the problem that you're working with? If so, you can find the zeros really quick right away and build the rest of the graph around it. If you can't factor it, then you can always do, especially if it's in standard form, you can do find the vertex, negative b over 2a, and then plug in points around that vertex and see, does it cross the x-axis? You can even do this in vertex form, where you figure out, do I go left or right, do I go up or down, and then graph that and see where it crosses the x-axis. So we're using all of our graphing components and the 3 different types of graphing to help us get the graph on there as well as figure out what the x-intercepts are. So my question to you is, which do you prefer? Do you like the graphing that we just did, or do you prefer the factoring? It's a personal question. I like both. Well, really, I am a factoring kind of person, so I like the factoring. But the graphing is good sometimes, especially if you need more than just the factors. Let's say you need the vertex, and you really want to see the range, and you want the y-intercept, and all of that stuff. A graph is really good to be able to figure things out. It just depends on what you need. All right, see you in the next video. Bye!